In this video, I'm going to talk about properties as they relate to C#. Properties are one of those things I just didn't quite get when I first encountered C# or when I transitioned over to it from C++. But now that I understand what they are and the benefits of using them, I just love them to death. And in fact, I start noticing them not only in C# but in other languages as well. The other languages have implemented properties. And I think once I show you some demos and explain the advantages, you will love properties as well. And after this video, I will provide a second one where I actually open up Visual Studio and then do a demonstration of how to use properties, how to create a class that represents a circle that has different properties for the radius, the diameter, and then the area. So I'll give you, this video contains the theory, or the reasons why we should use properties, and the subsequent video will give you an example of using properties in Visual Studio. So if you're thinking, yeah, great, I can't remember this, I'm never going to know how to do this when I go over to Visual Studio, don't worry, the next video is in Visual Studio. So let's talk about some basic object-oriented practices or principles before we talk about properties. Anytime we design a class, you can think of it as a vending machine. Like this vending machine has a public interface, but it has private and protected data inside of it, right? The public interface is the buttons that you push, or maybe the coin slot that the dollar bill thing you can interact with, and the credit card swiper, or maybe the slot where you can take your drink out. But there's also private and protected stuff there too, right? You don't want somebody to go in there and take all the Snickers or the Dr. Who, no, I don't know, Dr. Pepper, sorry, got sci-fi on the brain. You don't want people to go in and steal all the money and rearrange the inventory and then hit the button 3 times to tell the vending machine guy that the thing is empty and it needs to be serviced, right? You want to protect the internal state of that object, and by controlling the way that people interact with that object. So anytime you design a class, that class has a public interface that restricts how anyone can interact with that class, and that keeps the internal state of that object consistent. And typically, the way we've done this, at least the way I saw this done in Java and C++, was to use getters and setters. So getters and setters are kind of like in my mind, that's the old way of doing things. Nobody does that anymore. When we have the new way, which is properties. So getters and setters are public functions that allow you to get or set private data members. They restrict how someone can interact with a particular object. They provide a public interface for changing a private state, the internal state of an object. So if we were going to look at a class, in C#, and we were going to write this class using getters and setters, we would do something like this. And you probably did this in C++ or Java. You have private variables, and then you have some public getters, and then you have some public setters that take some, the new value and assign it to the private internal variable. So what we've got here is we have private variables for the internal state of this object, and we have public functions that control or that can get and set that those private data members, right? So we have a private internal state that we're trying to protect or limit access to, and then we have public functions that allow access in a controlled way to that internal state. So what we've got here is data that is private or possibly protected. Actually, I use protected more than I use private. And then we have public accessors, public getters and setters that allow us to change that private data. And if we wanted to do something, here's an example of using getters and setters. So maybe we make a new point, and then if we want to set the values of that point, put that point in a position, we have to use the setters. And then if we want to move the point, then we have to use the getter, add our bit number, and then use the setter to change the value that of that point, right? Where that point is. So this is really clunky and horrible, right? This is, it's just not very clean. We can't just say like p.x equals 50, p.y equals 50, right? We have to use these getters and setters, and it's a big syntactic, ugly mess, right? It's just horrible, right? I mean, we get why it is that way. because we don't want to accidentally somehow clobber or make the internal state of that object inconsistent. But it seems like we're paying a high price in terms of the cleanness of the code. So let's talk about properties now, because properties allow us to do the same thing, but the syntax is much, much cleaner. So C# properties are functions too. They work, they behave just like getters and setters, except the syntax is different. When we interact with a property, we interact with it as though it was a variable, and the syntax for that is much cleaner than making a function call. Properties have to start with uppercase letters, and we've actually been using them already. When we were playing around with the button of great annoyance that would jump all over the place, and we were changing the button's left and the button's top and the button's text and the window's text, and all of those things are properties. They're not private variables, they're properties. So I think I even used the word property. So these are properties of these objects that we can change, but I just hadn't really defined that a property has a specific meaning within C#. So to write a property, you just start by writing, they look like a function, but without the parentheses. So a property is really kind of a wrapper around a get accessor and a setter. A property is a wrapper around a getter and a setter. And that wrapper looks like a function, but without the parentheses. So if you are making a property that's an integer, it's going to look just like a function, but without the parentheses. And without seeing that in code, it's hard to envision what that looks like. So let's just actually kind of take a quick look. So let's say we were going to try to make a class that had a point, and we wanted to add a property for its X and Y position. So what we're going to do is make some variables, X and Y here, and we're going to make these lowercase and put underscores in front of them to indicate that these are private variables. These are internal class variables only. We're going to put underscores in front of them to indicate that those are private. So private means that the outside world, you can't come in and just change the X and Y of a point because it's private. And now what we're going to do is create a property that allows us to change X and change Y. Which Y? These private internal Ys. So what would that look like? So here, what we're going to do is make a property, and the property looks just like a function, but without the parentheses. So notice there's no parameters here, but it looks just like a function, like public int X. It's like, oh, where's the argument list? Oh, there isn't one, so this must be a property. So inside of these curly braces here, that's where we're going to put our getter and our setter. This public int X, this is defining a property. The property has a get and a set, usually. It turns out you don't have to have both. There it is. But that's how I remember that. A property, when you're writing a property, it looks just like a function. It looks just like a getter, but without the parentheses. All right, now how do we, you can see that there's a missing linkage here. How does this property relate to X, our internal X variable, where we're going to add it inside of these parentheses here. So inside of those parentheses, that's where our get and our set are going to go. So to return X, we write the word get and then followed by the curly braces, and then inside of the curly braces, we can write whatever we want, but we have to return an integer. And in this case, we're just going to return our internal private variable. So anytime somebody tries to read the X property of this object, the getter gets called and it says, oh, I'm going to return underscore X. So externally, people think they're interacting with this thing called X, but really what they're getting back is this underscore X. So really this uppercase X, this public X property, is kind of just a pass through, or it's kind of a I hate the term syntactic sugar, but I have to use it. I hate that term. So someone will interact with X, but what's really going on is the getter is being called under the hood, right? This is kind of a convenience notation. And then what about if somebody tries to set X? Well, we're just going to add, let's add a setter and see what that looks like. So set, and then our curly braces, and then let's put the code in there that sets X. Now, this kind of raises a question, right? Because what do we set X to? Like the underscore X, where do we get the value from? Well, there's a keyword built into the C#, and that is just the word value. So value means the right-hand side of the expression. So if somebody tries to set uppercase X, it calls our setter, and it will set the internal private variable to whatever the right-hand side of the expression was. So value is a keyword inside of C#. It's a keyword with respect to properties. All right. So if you wanted to write a property that didn't have any particular get or set logic, it was just like a plain old vanilla getter and setter. It didn't do any validation, right, or anything like that. You can just type prop tab, and then it'll stub out a property like this that just has get semicolon and set semicolon. This is it's called an auto implemented property, and what it does is it creates a private variable for you that is associated with X, and it would create a private variable here that's associated with Y. We have no way of knowing what the names of those variables are. Is there really any point to making properties like this? Kind of, not really. You're not getting any kind of protection by doing this. You're not getting any data validation by doing this. But there are times with respect to, like, I don't know, introspection, that you want things have to be properties versus private variables. So it doesn't hurt. It doesn't hurt to do this. All right. So if you need to write a property, just hit prop tab, and Visual Studio will stub it out for you, because Visual Studio is like auto completion is just absolutely amazing. So let's take a look at our point and see, using that property that we wrote to get and set X, how much easier does moving this point around get us, right? I mean, it is a little bit of work to write the property, but once it's there, our life becomes a lot easier when we have to manipulate the objects that have those properties. All right, well, take a look here. So we're creating a new point, and look, we can set X to 50 and Y to 50. This X, these are our properties right here. And when we set X to 50, what's really going on is that underscore private X is getting set to 50, and the underscore private Y is getting set to 50. So inside of that setter, 50 is kind of dropped in place of the word value. But notice that's a lot cleaner than using a setter. All right, and then, all right, I think I just said that. So notice we're using our properties like they're variables. There's no function notation at all. It's just a lot cleaner. All right, and then what if we want to move our point over, like from, by 100? Well, here what's going on is we're getting the property, we're getting the value of the property, adding 100, and then setting the property again. So the getter and the setter are both being called here. And isn't that a whole lot cleaner than what we were doing before, where you have to get the value, add 100, and then set the value? I mean, if you line them up side by side, right here on the left, this is when we're using the traditional getters and setters. And then here it is on the right using properties. Like, it's so much cleaner on the right. So that is one of the primary benefits of properties. It's just, it is syntactically so much cleaner, but that is not the only benefit to using properties. So let's take a look at why we would want to use properties versus, just public variables, or as opposed to not using properties at all. There may be cases where you want, if somebody changes one property, or that another property changes accordingly. So imagine that you have an object, and it can have a direction, and that direction, it has kind of has a sine and a cosine, right? It has a horizontal component and a vertical component. And if the direction changes, then the horizontal and the vertical component of that object's motion also change. So in the setter for maybe the direction property, you could also change the horizontal and vertical direction properties as well. So altering one property, setting one property, could have side effects and change other properties, and that would help keep your object's internal state consistent. Great use of properties. I see this in GameMaker Studio. You change the one property of something, its speed, its direction. All the other variables stay in sync. The object doesn't sort of explode because all the components are going in different directions. Changing one property changes all the corresponding properties that relate to it. That is a key advantage, a key reason to use properties. The other is data validation. So imagine that, if you just exposed a public variable, somebody could set it to some, nonsense value, something outside the range that would be valid for that particular variable. So you could also add validation logic to a setter, so that if somebody tries to set a property to an invalid value, something outside of the range it should have, then you can clamp that or scale that or bring that value back into range. So, for example, imagine that we had an angle, right? And an angle can be between 0 and 360 or something. So maybe they try to set it to 361. Well, what we want to do is, divide it by 360 and take the remainder. And that way the angle will always fall between 0 and 360. And, you actually see this in Game Maker. If you try to set something to, 400, it gets scaled down to, back to 40 degrees, right? So you allow having a setter that has validation logic on it will help you keep your object's internal state consistent. Now, and I mentioned this before, do you need to have both a getter and a setter? And the answer is no. You can have just a setter or just a getter. So here is a public property called health with capital H, and it is kind of a stand-in or a proxy for underscore health, right? Underscore health is the private variable. Capital H is the public property that is the proxy for that private variable. And in this example here, we just have a getter. We don't have a setter. That is totally valid. You can have a get-only property. Actually, if I were going to have a health property, I would have a setter on there, and I would put validation logic that if you tried to set the health to greater than 100, it would just cap the health at 100, right? That's a perfect example of why you should use a property. You keep your values within range. And then one other thing, what if you wanted to have a property that had a value? How would you do that? Actually, this might be an error right here. Let's rewrite this. Actually, I'll show you on the next slide here. If you wanted to give a property a default value, after the property, you just say equals and you provide the default value. So that's all you have to do. Actually, so what we really should have done here was we have a private variable called health, and we would put equals, equals 100. There we go. Something like that. That would be how we would set that to a default value of 100. So that's it. So properties are really just getters and setters. However, syntactically they are much, much cleaner. They help protect an object's internal state by controlling the way that private data can be accessed, both by providing data validation and by ensuring that if one property is changed, that all the related properties are changed accordingly. And then properties don't have to be both get and set. They could be get only and set only. And you can also, lastly, provide a property a default value by supplying that after the property, as I just showed you in the last slide in this example. So that's it for properties. Properties, the syntax looks a little odd when you first see them. Remember, just if you want a Visual Studio to write it out for you, just hit PROP and hit Tab twice. It will stub it out for you. But these are the two key reasons that you should use properties. You can have changes to one property propagate to another property, and you can impose or you can provide data validation logic that helps keep your properties within allowable limits according to your object's needs. So there you go. In the next video, I'll do the example in Visual Studio where I create a class for a circle and then provide properties for the radius, the diameter, and the area, and I will do. You will see how how they work actually in real life inside of Visual Studio.